Welcome. In this video, we are going to show a couple of things. First, we will demonstrate what the derivative of sine of theta is. I think every one of us knows what that is anyway, but we'll pretend we don't know that, and so we will fall back on the classical definition of the derivative to accomplish that task. Incidentally, we will be utilizing the results of the past two videos where we used the squeezing theorem on the first of the last two videos to show what the limit as x tends to 0 of that famous quotient sine x over x is 1. And so my message to you is, if you have not viewed the last two videos, it may be a good idea for you to stop this video, look at the last two videos, and then come back and watch this video. And then once we have shown what the derivative of sine is, then we will be able to evaluate the integral of cosine of theta, and that's just basically the antiderivative. So the powerful idea that is emerging from these videos is that when you know the derivative of something, you can always go backwards and do the antiderivative or evaluate the integral. So that is the idea for this video and the next video that is very much like this one. So let's go ahead and begin with trying to use a basic definition to evaluate what the derivative of sine of theta is. Let me just call my sine of theta my f of theta. And so the definition of a derivative from your calculus class is that f prime of theta is therefore equal to the limit as, let me say, delta theta tends to 0 of f of theta plus delta theta minus f of theta all divided by delta theta. And what we're really trying to do is figure out what that limit is, okay? And so, well, let's go ahead and do that. So we have this is equal to the limit of delta theta going to 0. The f of theta plus delta theta is obviously just going to be sine of theta plus delta theta minus the f of theta is nothing other than sine of theta, and this is all divided by delta theta. And now we've already seen this many times over, and we will continue to see this many times in the coming videos, but let's just remember. So let me say up here, recall the angle sum formula for sine. So sine of A plus or minus B is equal to sine of A cos of B plus or minus sine of B cos of A. And so if I apply that to this result right here, okay, then I can write this as the limit as delta theta tends to 0 of sine of the first angle cos of the second angle plus sine of the second angle times cos of the first angle. Okay, that's all of that stuff. So let me see if I can point to it so you see it. That's that stuff. Minus sine of theta all over delta theta. Okay, and you may say, wow, that looks even messier than what you had before, and I would agree with you, but we need that to invoke what we've done in the past two videos so that we can actually evaluate all of this. And so now let's go ahead and clean this up a little bit so that it looks like something that we can recognize. So the limit as delta theta tends to 0. Okay, so the first one I'm going to write, so this is the limit as delta theta is going to 0. So let me write this rather in this way. Let me pull out, on the first term, let me pull out the thing that isn't being influenced by the limit. So I'm going to write this as the sine of theta And so I'm going to get the limit of the remaining term, which is cos of delta theta. Okay, that's that next term. And then I also have a sine of theta out here. So let me say that that'll be minus 1 for it, okay, divided by delta theta, okay, plus, okay, so let's do this, plus, now in this second one, or in this middle one, I have a cos of theta, which isn't going to be influenced by the limit. So let me pull it out like I did for this one. So I get a cos of theta times the limit as delta theta goes to 0 of, well, what do we have left over? We have sine of delta theta over delta theta. And now as we stare at these bracketed terms, well, the one on the left, this one right here, is from the last video. So see previous video. And then if we look at the bracketed term on the right, I would say see video from 2 videos ago. Okay, so we've already shown what those results are, and that's why we produce those videos, so that we can actually show this. We showed that the one on the left, this thing is going to go to 0. And we showed that this one on the right is going to go to 1. So let's put all of that result together. We have sine of theta times 0 plus cos of theta times 1. And so we have now shown that the f prime of theta, which is to say the derivative of sine of theta, is equal to cos of theta. Okay, so that's wonderful. We already knew that, but we've now, in a very formal way, together with the last 2 videos, have formally proven this in a conclusive way. Now we're going to be able to use this result to do the antiderivative. So let's do that. So, okay, so I have now, from this result, I have d of sine of theta is equal to cos of theta d theta. All right, if I just multiply through by the d theta, and now I integrate both sides. So here's my little abbreviation for integrate both sides. I'm integrating both sides. I get the integral of d of sine of theta is equal to the integral of cos of theta d theta. And we know that the integral of d of anything is that anything plus a constant of integration. So that is pretty much the long and the short of what I needed to do to fulfill the second part. That is to say that the integral, or the antiderivative of cos of theta d theta, is equal to sine of theta plus some constant of integration, very simply. And so that basically is all I needed to do to show that. So the message that maybe we showed 2 powerful messages in this video. One is how to apply the definition, that is to say this guy right here, how to use that definition to actually, or rigorously, show what the derivative of some function is. In this case, sine of theta's derivative is cos of theta. And then once we know that derivative result, we can back out the antiderivative really, really simply as we just showed here. It's essentially a one or two step process, however you want to look at that. Okay, the next video is going to be analogous to this one, and instead of doing the derivative of sine and the integral of cos, we'll reverse those roles. We'll do the derivative of cos and the integral of sine. Thank you, and we'll see you in that video.